Okay. Well, thank you very much for the invitation to come over to Butte this afternoon. It got me out of half of a class this afternoon. I had to cut short a little bit, but that's okay. Beautiful drive over the pass this afternoon between Bozeman and Butte. A few clouds down by Dillon, but just a beautiful day to get off campus and come over to Butte and see a bunch of old friends and faces that I haven't seen for a long time. So anyway, I'm happy to be here. Do we want this thing up here? Does that go away or does that stay there?
No, I think it goes away.
No, it doesn't.
Unless you make it go away.
That's okay. Yeah. So today I'm going to be talking about an expedition that we went on a couple of years ago to Mount Everest and do a little bit of comparative mountainology. Just kind of a general, comparison of what was going on in the Everest region relative to what was going on here in Montana at about the same time. And this expedition started several years ago as a brainchild of Conrad Anker, who lives in Bozeman. Probably most of you have heard of Conrad Anker. He's a world-class mountaineer. He's been all over the world climbing mountains throughout his career. He's about 50 years old now. And he's been the lead climber for the North Face Company, the sponsored team of climbers that go out and do fantastic ascents all over the world, sponsored by North Face, so you can see them on big posters and TV ads and whatnot wearing North Face equipment. So he's the guy that's been in charge of that climbing team for probably over 20 years now. And of course, he's famous for having found the body of George Mallory up on Mount Everest, wrote a book about it. Prior to our expedition, had been on the summit of Everest twice, and he wanted to make an ascent to commemorate the 50th anniversary of the first American ascent of Mount Everest, which was done in 1963. And National Geographic ended up being a major sponsor, of course, as they were of the 1963 expedition. And so they wanted us to do this 1 year in advance so they could write up their bulletin articles and their various things and magazine articles and get those published on the anniversary. So the expedition actually took place 49 years after the first American ascent. And so Conrad and I spent many, many days in Bozeman having lunch at the co-op downtown and talking about this. And it sort of developed and snowballed from that. This shows Conrad, by the way, on his second ascent of Mount Everest. There's the summit. This is along the North Ridge on the second step there at 28,700 feet. So again, it was to commemorate the first American ascent done in 1963. And of course, this is the iconic photograph of Barry Bishop, who went on to become the director of research at National Geographic, had a long history at National Geographic, retired from Nat Geo, moved to Bozeman, was going to join our faculty as an adjunct retired person and teach some classes and work with students. And that summer he was killed in a car accident in southern Idaho on his way to the American Himalayan Institute meeting in San Francisco. So it was kind of a tragic loss. This is looking down almost on the summit of Mount Everest, which you can see right there. Our access was up the western Coombe, up the Khumbu Glacier, up Lhotse to the South Col, and then up the southeast ridge to the summit. Back in George Mallory's day, he basically came in the Rongbuk Glacier and came up the north face and onto the northeast ridge and on up to the summit in this direction. This is all in Tibet or China. And so that was basically not something we could really do 2 years ago. Conrad did want to climb the West Ridge. And this is something that has not been done in the style that the Americans did it since 1963. That is, two guys without Sherpas, carrying light packs, minimal oxygen, climbed up to the West Ridge, made a dash for the summit, and then came down the southeast ridge to the South Col. A complete traverse in a light alpine attack fashion. That has not been done since 1963 when two Americans did it. 25 people have tried doing that. Excuse me, several expeditions have tried doing that. 25 people have died trying to do that. So it was a major objective to try and accomplish that again 2 years ago. Unfortunately, the weather just did not permit it. So our expedition was largely restricted to the Southeast Ridge. We had several sponsors, and I'll talk more about that in just a second. This is just a view of our Chorten at Everest Base Camp. My theme was geological research, seafloor to summit. How do these rocks get up here? What are they composed of? What's their age? What do they look like? And so the scientific aspect was funded by National Geographic, and I had some major funding from Montana State University Foundation, several donors that wanted to see this expedition move forward with MSU. We also had a major grant from National Science Foundation for education and outreach, and this was targeted for Montana 5th grade students. We wanted to bring the expedition into the classroom, have students follow along, understand how glaciers operate, how climate operates over the Himalayas, what the different rocks are on the mountain, kind of turn it into a laboratory experience for students across Montana. And I thought this was a nice idea. I had no idea that this would become the dominant part of the expedition, and by far and away the most successful part. This education and outreach program actually went nationwide. We had schools from coast to coast participating. And then the North Face, of course, was a major contributor in terms of equipment and sponsorship as well. So it was really a partnership between NSF, Nat Geo, MSU, and the North Face. This was critical to the expedition. It took me 6 months to get this piece of paper. It's written in Nepali, so you can't read it, but it's my rock collecting permit for the Bureau of Mines of the country of Nepal. And I didn't have to bribe anyone. It didn't cost me any money. It just took forever to go through the bureaucracy to get this little piece of paper. But we couldn't have gotten anything out of Sagarmatha National Park, which is the Nepali term for Mount Everest, let alone out of the country of Nepal, were it not for this piece of paper. It's pretty short and sweet. It just says we get permission for Dave Lageson from the U.S. to collect rocks and take them back to the States. But sweated blood, sweat, and tears to get that thing. This was the gentleman who was my hero, basically. Donaru Sherpa from Fort Say, Nepal. He's early 30s right now. He's been on the summit of Mount Everest 16 times. He's a really big Nepali Sherpa. He's about 6'2". He's lean and mean, incredibly muscular, and he's a superhuman. He basically collected our samples from the summit down to the South Col and gave us one of the best rock collections off of Mount Everest that has ever been collected. Prior to this expedition, only a few rocks have come off the top of Mount Everest, trophy rocks collected by climbers, and maybe one or two might end up in the hands of a geologist somewhere. So based on that, we knew there was limestone up there. We knew it was Paleozoic, suspected it was Ordovician, but beyond that, didn't really know much about the summit limestone at all. So this shows Donaru on summit day. You can see the crowd in the background. This is some MSU equipment here in the foreground. We had Trimble GPS, and we couldn't get an accurate GPS summit elevation because of all the dang people up there. It was absolutely nuts. There were only 2 days in 2012 where you could reach the summit of Mount Everest. And it's because of the jet stream. It just stayed down on top of the summit every day, day after day, week after week, with winds of 150 miles an hour. We had 2 days where the jet stream lifted off the top and you could get to the summit. This was a bitter cold day. Everyone up there, including Donaru, got frostbite, and we were lucky to get what we were able to get. Just a picture of Donaru and myself, much lower elevation. This is down at Camp 1, which is about 21,000 feet. Early on, I was told, I never used an oxygen mask, but I was told, in case you have to use oxygen, you better get rid of the mustache and don't grow any whiskers and stuff like that. So I did that. I shaved at Everest Base Camp at 18,000 feet. Well, Mike knows I've had a mustache since I was a little boy, practically, and you don't shave a mustache at 18,000 feet on a glacier. And I instantly cracked and bled. It was just miserable the whole time, basically, from sunburn. So that's my bald face picture. This guy was a tremendous help. He still is a tremendous help. He's my graduate student working on this project, Travis Korthouts. He received his bachelor's in geology from MSU, and now his master's thesis is the summit rocks from Mount Everest. And he's just doing an absolutely great job. He's a climber. He did a lot of climbing in the Andes during his college career, and so he knows his way around the mountains. Got to thank the yaks. I fell in love with yaks. They carried our gear in. They carried our rocks out. We ate yak meat. We drank yak milk. We ate yak butter. Yaks sustained us. They were delightful to hear on the trail. You'd hear the bells under their necks. They were just fantastic, beautiful animals. Just different pictures here. I probably got carried away showing too many yak pictures, but you can see them coming down from Everest Base Camp here. This is Pomori in the background. Trekking across the Khumbu Glacier, carrying mostly empty containers here coming off Everest Base Camp at this point. But beautiful animals, big, furry, shaggy, gorgeous-looking beasts that can carry just a ton of equipment. Here's a young yak at considerably lower elevation. This is in a village at about 12,000 feet in the Khumbu Valley, and that's a baby yak. And they always tied up the baby yaks and put them in the center of the village, tied them up with a rope, especially at night. Why would they tie up a baby yak at night and put him in the middle of a village? Yes?
So that the foxes and predators won't eat him.
Bingo! Specifically snow leopards. Snow leopards over this part of the Himalayas, they love baby yaks. It's like a yummy hot dog. So they got to really protect these things and keep them from being attacked at night by snow leopards. I'm just going to give you a quick introduction to our trek up the Khumbu Valley. After one of the longest flights of my life, Los Angeles to Bangkok, 18 and a half hours. We flew to Kathmandu and tried to spend as little time in Kathmandu as possible. How many have ever been to Kathmandu? What's your impression of it?
Chaos.
Chaos. Utter, complete chaos, especially in terms of the traffic. It's beyond me why 50% of the population isn't dead within a week just through traffic accidents. It's unbelievable. No stoplights, no stop signs, no traffic control. Everyone going 90 miles an hour like a bunch of bees in a beehive. It was complete chaos. Very polluted. I could hardly wait to get out of there. So we flew into Lukla. This is an airstrip that was built many, many years ago by Sir Edmund Hillary, so he could fly supplies into the Khumbu Valley and build schools for children. In recent years, of course, it's been paved, and he was a pilot, and he probably has heard of Lukla Airport. The runway has an angle, I kid you not, about like that. There's a huge cliff down here, and there's a huge cliff on the uphill end. And the pilots were just spot on. It was like landing on an aircraft carrier. And one of the smoothest landings I've ever felt in my life, other than with Hugh, was landing at the Lukla Airport. Unbelievable. So we started our trek at Lukla, up the Khumbu Valley, looking at these tall Himalayan peaks, just being kind of awed by them. This was mid-March 2012. And after a couple of days, you basically end up at this gate right here. Well, actually, the gate's right there. There's an army post right here, and this is the entrance to Sagarmatha National Park. Sagarmatha, again, being the Nepali name for Mount Everest. The Nepalis invented that name. The rest of the world calls it Chomalanga, Mother Goddess of the Earth, or, of course, using the British name, Mount Everest. So you drop down into the canyon here of the Dukosi River, and 10 days later, you're at Everest Base Camp. You start your trek at 9,000 feet, you end at 18,000 feet. And you want to take 10 days to just acclimate to the increasing elevation. Dukosi River Canyon is absolutely beautiful. You hike along the bottom, and then you climb up and cross on bridges and climb down and back and forth and go through a variety of villages. One of the more famous villages here is Namcha Bazaar at 11,286 feet. It's in a horseshoe canyon here, and it has a big spring groundwater spring gushing out of the mountain, and that's why the village was settled centuries ago by Tibetan traders coming down from the Tibetan plateau. Am I standing right in your way? I think I am. Uh-oh. Tibetan traders to trade with the Nepali people. I think I moved once and then I forgot and moved back and blocked your view. But anyway, this is just a beautiful little village. I should have shown a picture, stuck in a picture of a little bar down here in Namche Bazaar that had some tables out front, and they were playing music on speakers. No big deal. You'd go have a Nepali beer and listen to the music. Well, when I had my Nepali beer at that bar, they were playing Stairway to Heaven. And so the next day when we started trekking up the valley, that's all I could sing was Stairway to Heaven. And it literally was. You're going up the side of these incredible canyons on these old Tibetan trails that, are thousands of feet above the valley floor. Above Namche Bazaar, this is my first good view of Mount Everest. You can see Mount Everest right there. And Mount Everest seems to be the only peak that has the snow plume coming off the summit. This is Lhotse right here, and this is Nuptse right here. And together, Everest, Lhotse, and Nuptse constitute the Everest Massif. And so it was just a wonderful thing to finally see it on the ground. One of my favorite villages we went to here was called Tengboche Monastery. And that's their backdrop. There's Mount Everest, there's Nuptse, there's Lhotse. And you can see this Tibetan monk here doing his morning wash right there outdoors. This is at an elevation of 12,664 feet. And it was just an absolutely magical place. At Tengboche Monastery, there's a bunch of monuments to famous climbers that have died on Everest, including Barry Bishop. Of course, he did not die on Everest, but he was so highly acclaimed that the Nepali climbers created this monument to him right there. So this is a plaque to Barry Bishop, and we stopped and put our prayer scarves around that monument and paid our respects to him. So on the Dukosi River Canyon, on up towards Mount Everest, there's Everest, Lhotse, Nuptse. Come across this beautiful peak right here, Amadablam. Barry Bishop was the first person to climb Amadablam, by the way. It means Mother's Necklace. The summit rises to over 22,000 feet. And the Dablam, or the necklace, is this perched glacier right here. Reminds me of the hanging glacier on the face of on the face of Mount Moran, rather, down in the Teton Range. And so it's like a mother with a necklace on her throat, and her arms are spread out to embrace her children in the Khumbu Valley. And that's how the Nepali people view it. So here's one arm, and there's her other arm spread out to basically embrace the people of the Khumbu Valley. Absolutely a gorgeous, gorgeous peak. And when you're trekking along, it's just, it's hard to get a sense how big these peaks are. They're absolutely staggering. They're enormous. But you get a sense when you look up to the summit and you basically break your neck trying to see the summit, They just soar above you. Putting up towards Everest a little closer, we're now up to almost 14,000 feet in the valley of Farache. Here's the village of Farache right here. This is meltwater coming out of the terminal moraine of the Khumbu Glacier, which is right up here. So again, mid-March, this is still sort of late winter, early spring, and the vegetation here hasn't really taken off. There isn't much vegetation, but the tundra grasses aren't really growing yet. During the summer monsoon season, this is more or less green, and this is where the yaks come and graze. Yaks don't do well below about 14,000 feet. The Tibetan Plateau, the average elevation of the Tibetan Plateau is 15,000 feet. Yaks love it up there. So you get them below 13 or 12,000 feet, they just don't do well at all. So this is a good place for yaks during the summer monsoons to just fatten up. So on we trek up towards the Khumbu Glacier. This photo doesn't really do justice to the terminal moraine, but it starts way down here and goes way up there. And this is just a segment of it. You're just barely seeing the top of it here, and a little village here called Dugla, where you stop for a little a little tea of some sort to try and stay hydrated as best you can. And finally, you get up on top and you see the lower ablation zone of the Khumbu Glacier. Way back here in the distance will be Everest Base Camp. And this is a typical afternoon photograph. Every morning was bright and sunny and crystal clear, and then around noon, 1 o'clock, the clouds would build up, they'd come up the Khumbu Valley, and by mid-afternoon you'd be in a blizzard. It just happened every single day that way. Big lateral moraine here behind me with lots of monuments on it. Next morning it looks like this, you know? And it's just stunning. I mean, to see this, I couldn't believe it. I'd fall to my knees. These are names I've read about ever since I was a kid growing up in Denver reading about the 63 American Everest expedition. Here's Nuptse, the west shoulder of Everest, Changse in Tibet, Lola Kal right there, Kumbutse, Lingkran, Pamori off to the left. I mean, these are like the gods of the Mount Everest region, these tall peaks here. And just an incredible zone of ablation on the lower Khumbu. It's basically deflating. I mean, it's not so much receding backwards, it's just deflating on itself. And it's quite incredible to see the amount of relief on the flank of that glacier due to deflation. Here's Pamori. We're trekking along the lateral moraine now. This rises up to 23,507 feet. This is not a vertically exaggerated photograph, you know. They're just stunning peaks when you see that kind of relief. And here you can see a beautiful view along the lateral moraine. Here's the lower Khumbu. Everest Base Camp is right up there. There's the Khumbu Glacier. And here are some yaks coming down from carrying gear up to Everest Base Camp. So now we're getting closer to Base Camp. Finally, we see the summit of Mount Everest. There's the west shoulder. Here's Nuptse. There's Changse in Tibet, a peak I would love to get on. And then Kumbutse right here. And that's Everest Base Camp. I don't know if you can see some little yellow dots right there, but those would be North Face tents. And so zooming in, there she is. There's Chomolungma, Mother Goddess of the World, with the ever-present plume of snow blowing off her summit with the jet stream in late March. And finally you get to this rock called, you know, it's just labeled with a magic marker, Everest Base Camp. And this is as far as the trekkers go, the tourists go. Base Camp is back here. Trekkers are not allowed to go into Base Camp, although some do. But the idea is to try and keep Base Camp as clean as possible, minimize the amount of peeing and pooping that goes on is the fundamental problem. And it's dirty enough without having just lots of people come in every day, leaving their soil behind them. Notice that I'm just wearing a t-shirt here. So this is like late morning, 11 o'clock or something like that. It might get up to 30, 35 degrees. So it's cool, you know, but you're hiking along in this blistering sun, you're carrying a pack, you're working up some aerobic sweat, and it felt comfortable just to peel down to a t-shirt. And finally, we set up Base Camp for our particular expedition. There were many expeditions that particular year. There was about 400 people in Base Camp in 2012, 450, something like that. And we had a big ceremony where we erected our big pole on the Chorten, put out the prayer flags. A Buddhist monk came up from the Khumbu Valley and had a ceremony that lasted a few hours. So this is my home for about 2 months. That was Travis's home right next to me. That's where we ate. And you're basically camping on a glacier. A daily situation that you would constantly hear would be the avalanches coming down. Constantly coming down, sometimes carrying the snow over Base Camp in terms of light dusting of powder snow and whatnot. But we would hear as many as 10 to 15 avalanches per day coming down from the peaks surrounding us. And they had a distinct, deep rumble. And usually by the time you heard the rumble, the avalanche was mostly down the mountain. This was a big one that happened in the morning. It broke off the flank of Nuptse and came down and hit Camp 1. 15 minutes before this avalanche, there were 50 people in Camp 1. Roughly 25 went up the mountain, 25 came down, the avalanche came down. It only ended up injuring 3 Sherpas that were left in camp. One Sherpa was really, really badly injured and I think later died, but it could have taken out 50 people. And this could have been the most tragic day in Everest climbing history, but the timing was just fortuitous. And that's the tail end of the avalanche coming down. When we heard this and saw this, we knew that there was bad mojo going on at Camp 1, and there was all kinds of radio chatter on the mountain. This was our nemesis. We had to get up through the Khumbu icefall, and this was very dangerous because this glacier was constantly avalanching, basically calving off giant blocks of ice that then would disintegrate into big avalanches. And you had to go right underneath of this thing. So we would start, there's that glacier right there, and it had these two fangs hanging down, and the path took you right underneath of that. So our route was up the left side of the icefall. And we'd start climbing about 2 in the morning with headlamps, and the goal is to get up here before the sun rises. And it would take a Sherpa 2.5 hours to do that. It would take an old guy from Montana 7 hours to do that, you know. So I didn't make it. I would typically get up here before, after the sun came up. But at least the idea here is to do it at night when things are frozen and cold, as opposed to during the day when the sun is beating down. So that's a shot of what the icefall looks like. Again, here are those two fangs hanging down. The path takes you up in through here. You can see the Khumbu Valley back here, these beautifully folded Cambrian metadolomites. Lots of crevasses to negotiate. There was something like 70 ladder crossings on aluminum ladders across crevasses. This shows one of them right here where they've lashed 3 ladders together. And there's little safety lines that you clip into with 2 carabiners, but it's not climbing rope. It's called Korean boat rope. It's plastic boat rope from China. And no way, if you fall on it, is that going to support your weight. The only purpose that rope has is it's anchored at either end, and you pull tension on it. And you keep tension on it with your hands like this, and that stabilizes you when the ladder starts to wobble. So you take a step with your crampons, put your front crampon on the front ring, your back crampon spikes on the back ring, one step at a time, pulling tension. And if the ladder starts to wobble, you just lean back against the rope and it stabilizes it. Then you do the next step, so forth and so on. It's a steep learning curve. There's no way to practice this. And this is not bravado, it's the truth. My wife asked me if I was terrified doing it, and my answer was no, because you are so intensely focused on where your foot is going on that ladder that you're not even looking into the crevasse. You don't want to look into the crevasse, first of all. So you're just watching your feet. Total 100% concentration. You get to the other end, then you do get scared. But out over the ladder, it's kind of like your mind is so totally focused on this that you're not thinking about much of anything else. This is my first time doing anything like this. I mean, I've climbed the Tetons and stuff and other peaks in Montana, Granite Peak, but those they ain't the Himalayas, So it was a Wild West experience. You cross a lot of snow bridges. Finally, got up to Camp 1 at 21,000 feet and pretty much fell down and was glad to be there. I show this crevasse. You can see how the ladders are overlapped like that and lashed together. This is the hard part to cross because now the spacing of the rungs is all screwed up. So what do? And this was the hardest part right here. A few days after I took this picture, the Sherpas would typically not clip in. They're so used to crossing these things that they would just pick up a rope with their hand and kind of trot across these things. A few days later, a young Sherpa was doing that. He tripped in the middle and fell to his death. And there were several Sherpas killed during our season there in 2012, and it freaked out all the other Sherpas. So it was a big tragedy. Well, this is how the Swiss had to do it in 1952, 1 year before Hillary. They basically had to span the crevasses with ropes and do it the old-fashioned way like that. Or they brought up logs from the Khumbu Valley, and there's the rope that he's pulling tension on, and you cross on a single log. So a little more harrowing than the ladder crossings. So we get up to Camp 1 at 21,000 feet. You're up there mid-morning. Beautiful sunshine. You rest. You have some tea. You look around. And then in the afternoon, the blizzard sets in. So you basically spend the rest of the evening, afternoon and evening, hunkered down in your tent trying to stay warm. Next morning, it looks like this. Beautiful sunshine again. You're looking up the Khumbu Valley. There's Lhotse. There's Nuptse. This is the southwest face of Everest, draped in this beautiful veil of clouds. And you hear this deafening roar. And the roar is the sound of the jet stream off the summit of the peaks. It's just incredible. And then we move on up to Camp 2. This is at about 21,200 feet on the Khumbu Glacier. And this is advanced base camp, basically. And no one's using oxygen at this point. This is our cook tent. This is where we ate and hung out. This is my little tent. First morning I climbed out of my tent, I realized it had been pitched at the site of a former latrine. There was a big pile of poop, frozen poop, right in front of the entrance to my tent. But it was so completely frozen, it was a non-issue. It was just like a rock. Still, it was kind of creepy to crawl over. I got above Camp 2 up in the Lhotse face, and the year we were there, and this is typical of Mount Everest nowadays with climate change and lack of snow, and the monsoons aren't doing what they used to do. There's no fresh snow in the mountain, especially from the winter time. And so the mountain, all the Himalayas are losing their snowpack. And basically bare glacial ice is being exposed that's impregnated with rock. And so climbing up the Lhotse face, rather than being able to climb up on snow and kick in steps and have a stairway to heaven like they've done in the past, it's all blue ice, front pointing your crampons 3,000 feet up with rocks cascading down on your head. So I described the situation to my wife, and we had a long heart-to-heart over a satellite phone, and she broke down crying, and I broke down crying, and we decided this was as high as I was going to go. I'm not, this is my first time. I'm not an experienced Himalayan mountaineer, and so I made it, that's a self-portrait. That's as high as I went on Lhotse, above 22,000 feet, and that was my summit. We had Sherpas, again, that were more than happy to do the rock collecting, and believe me, we paid them a lot of money to do that rock collecting for us. So that was kind of the trek in, as far as I went at least. So here's a good view of the west ridge of Mount Everest. Here's the southwest face, the west ridge, the north face. This is the col, the Hornbeam col here that was climbed in 1963 by the Americans. Unsold and Hornbeam, and they came into this gash, into this crack, and ascended up to the ridge, made the summit, and then came down the southeast ridge. Again, that has never been done. This photograph was taken when we were on Everest, and this thing was just a bowling alley of rocks coming down. It was unclimbable, and so they couldn't do it. But this lower portion of Everest is called the Everest Series. It's also known as the North Col Formation. North Col is off to the left. Here's the famous yellow band high on Everest, which is a dolomite. Top of the yellow band is a big detachment fault, sort of like think of it as like the Hart Mountain Detachment down in the Bighorn Basin. This is the Chomolungma Detachment Fault. I'll say more about that. And then on the summit, it's been named the Mount Chomolungma Formation. So that was our objective. Scientifically, from a research standpoint, that was the low-hanging fruit on Mount Everest. Lots of people have worked down here. Hardly anyone has really worked on these summit rocks. Down low, even the Swiss in 1952 identified the North Col Formation as imbricated schist steps. It's basically a phyllite, but nevertheless, they recognized it as a metamorphosed mud rock that could be climbed, sort of like, I suppose, the Matterhorn in that sense. Very similar type rock. And so this is one of my pictures taken above Camp 2. I'm looking straight up from the Khumbu Glacier to the summit of Mount Everest. Here is the Everest Series, the North Col Formation, which is Cambrian in age, we think. Here's the yellow band, which is Cambrian or Ordovician in age. Chomolungma detachments on top, and here's the summit limestone right here. So that was the objective. Let's try and get as many samples of the summit limestone as possible. This just shows you more of the North Col Formation at Camp 4 on the South Col. This marks the beginning of the death zone. Above this elevation, you need oxygen, unless you're an abnormal human being. Conrad Anker climbed Mount Everest for the third time this season, 2012, and he did so without oxygen. But he also suffered some temporary brain damage from it as well. I mean, it was debilitating. And they did some cognitive tests before and after at the Mayo Clinic, and it wasn't anything long-term, but you climb at those altitudes without oxygen, you're going to pay a price, basically. But here's this Cambrian Everest series. Again, more of it right here as you come up into the South Col. This is the Southeast Ridge route right there. Again, the imbricated schist steppes. The Swiss almost made it to the top in 1952. They got to the Hillary Step and were forced to turn back. And the next year, of course, the dang British did it and ousted the Swiss. So, here's one of our photographs showing the Everest series. Down below that is the Greater Himalayan series, including a lot of light-colored granites called leucogranites. So again, our objective was a summit pyramid here. Two people have really studied these rocks in any detail. The first one was Noel Odell, who was with the British Mallory expedition in the mid-1920s. He was a British geologist, and he was the first one to really, gather some rocks on the north ridge of Everest and do some work on these rocks. The other one was Augusto Gonzer, 1910 to 2012. I think of all the geologists I've ever read about, this guy has got to be my hero. He was an Austrian geologist. He basically mapped the Himalayas from the west end to the east end throughout his career. Published a tremendous amount of great work on the Himalayas. So from these guys, we know that it's marine seafloor limestone, it's fossiliferous, we see shell fragments in it, and it's Paleozoic. Based on work in Tibet, where these rocks are found at much lower elevation on the Rongbuk Valley, we know that it's probably Ordovician in age, 470 million years old, based on biostratigraphy. So, where do these rocks come from? How did a piece of ancient carbonate seafloor end up on the Earth's highest mountain? What's the story of uplift of the seafloor to the crown of the planet? This shows those Canberra Ordovician carbonates along the Chomolungma detachment down along the Rongbuk Valley in Tibet. Hard to get to, more expensive to go through China. They have huge fees that they charge you. And this photograph is courtesy of Micah Jessup at the University of Tennessee. He still hasn't gotten his rocks out of China. They won't ship them back to the United States. So you can go there, you can do field work. Good luck getting anything out of the country. So another reason why we wanted to focus on Nepal. Here's a peak I'd love to climb, Changsi. Huge amount of summit limestone, Mount Chomolungma Formation on Changsi above the yellow band here at a lower elevation than the summit of Everest, 24,000 feet. Very accessible peak to climb, but again, it's in Tibet, it's in China, so hard to get samples out. So just by comparison, here's our little comparative mountanology looking at the northern Bridger Range in southwest Montana. We've got Cambrian rocks on the west side here. This is from the summit of Sacagawea, and these would be equivalent to the Everest series. Devonian and Mississippian here, which we don't see on the summit of Mount Everest. So stratigraphically speaking, if we had Ordovician rocks in this part of Montana, the summit of Mount Everest would be right there. Well, I suppose I could have just gone down to the Bighorn Basin of Wyoming and seen the Bighorn Dolomite. It's essentially the same thing, essentially the same age, essentially the same rock. And this shows the Bighorn Dolomite in Wind River Canyon between Shoshone and Thermopolis. Here's a nice Cambrian section, and there's the Bighorn Dolomite right there. But been to Wyoming plenty of times, funner to go to Mount Everest. So, what did we expect to see out of these rocks once we cut thin sections? Take a look at mid-Ordovician life. We're dealing with the Paleotethys Ocean. I'll show you some paleogeographic maps here in a second. But this is one view. This would be Middle Ordovician 458 million years ago. And so here you can see the Paleotethys Ocean extending to the north, basically, of Gondwana. And this is a little wedge of India right there. There's Antarctica, Africa, South America, and this must be Africa right over here still. And so the depositional environment would have been on this carbonate shelf off the north coast of India at this time. What was going on here during the Ordovician? Well, it was a time period dominated by marine metazoan invertebrates, bottom-dwelling, filter-feeding organisms, obviously with calcium carbonate shells, very high sea level worldwide, highest sea level stands of the entire Paleozoic. Greenhouse conditions. It began with a major explosion in marine life, of major adaptive radiation amounting to a fourfold increase in marine fauna. Ended with the second biggest extinction in Earth history. And so this is from a paper that was published in GSA Today several years ago, showing geologic periods here throughout the Paleozoic up to the Tertiary here. And here's the Ordovician. And this explosion at the family level here in terms of marine invertebrates is called the Gobi, the Great Ordovician Biodiversity Event. So quite literally, the summit of Mount Everest captures one of the greatest evolutionary biodiversity radiations in the history of life on this planet. And I think that's pretty cool. So what was it like on the Ordovician seafloor at this time? We'll just go to the bottom here, off the north coast of the Gondwana supercontinent, the Indian continental shelf. One could expect to see a variety of brachiopods, rugosa coral, gastropods, a few trilobites, graptolites, and these big nautiloid cephalopods. Those would be some of the typical marine invertebrates you might see. Various dioramas from museums, this one for Ordovician time, showing basically a living biogenic factory of carbonate sediments accumulating on the seafloor. Thriving, teeming biogenic carbonate factory. You can see the crinoid gardens in the background there. Well, the first person to discover fossils in these rocks, again, was Noel Odell, who also was the last person to see Mallory and Irving alive as they headed towards the summit of the mid-1920s. Of course, they never came back down, and it was decades later until Conrad Anker found Mallory's body. Irving has never been found. So Noel Odell thought he found essentially some sort of plicated pelecypod. Okay? What in fact he discovered was nothing more than cone and cone structure. And here's just a generic example of cone and cone structure. We see the same thing in Cretaceous mud rocks here in Montana. It's produced by sedimentary compaction and whatnot. And it's not a fossil at all. But nice try. Others have found crinoids, modern crinoids shown up here, fossilized crinoids down here, of course showing the abundant stems that we find in Mississippian rocks across Montana. And the first person to identify those was Augusto Ganser. This is Augusto Ganser when he was a young man working in the Himalayas. He had to dress as a pilgrim, a Tibetan pilgrim in this clothing to go unnoticed, basically, because he had light hair and blue eyes. He's Austrian. So he had to kind of camouflage himself to go about the countryside and not be hassled. This shows him towards the end of his life. Again, I think the dates, he lived to be 101 years old and was active right up into the end. And so he studied rocks that were brought back by the American Mount Everest expedition in 1963, as well as a few rocks from the British expedition in 53, and he identified fossil fragments as being crinoidal in these Ordovician limestones. For a long time, they thought these summit limestones were late Paleozoic, not Ordovician. This is a slab that has been stained with the alizarin red S, so calcite stains red. You can see it's basically interbedded limestone and dolomite. And it's highly diagenetically altered for sure. We see saddle dolomite, we see structural textures in the rock that indicate shear, ductile deformation. Prior to this, most people just called it Ordovician limestone, gray Ordovician limestone. This shows the final ridge up to the summit right there with the outcrops that we sampled. This one shows several sample localities right down through the yellow band. We're throwing an army of tools at this, including, of course, my new Zeiss microscope, which I'm very proud of, cathode luminescence, XRD SEM, FESEM. We're doing stable isotope analyses and a variety of structural fabric analyses using optical digital techniques. So, this is one thin section that Travis just took a photograph of a few days ago of the summit limestone, showing some crinoid fossil fragments right there. And aside from the crinoid fragment, you can see that there's definitely a swirly textural fabric to this rock. It's undergone ductile shear, no question about it. There's a lot of internal strain. This is just zooming in on that fragment again. Here's a nice little shell fragment, unidentifiable right here from the summit again. So on this one now you can see some of our sample locations moving down, not including all the ones that went on down, but through the yellow band here. There was kind of a gap in through here where it was mostly snow and they couldn't get rocks without traversing out over this face. So that didn't happen. So what you see in thin section here would be a couple of generations of fractures here. This one is filled with saddle dolomite, and it's been completely recrystallized and cross-cut by this one, which still has kind of a gouge zone going right through the middle here. The red stuff is calcite. The white stuff is mostly saddle dolomite, that is Baroque dolomite, with small scatter grains of quartz here and there. And this is just zooming in on that guy right there, which is right there, showing this recrystallized fracture zone. And here's another one that was collected off an outcrop called Butcher Rock, which is just down from this guy right here. There's the summit. And what you see is a wraparound foliation pattern around massive dolomite right there. So again, indicative of ductile strain, ductile shear within these rocks. That's something we can measure and quantify. The next sample I'm going to show you was taken at the base of the Hillary Step. There's the Hillary Step right there, leading up to the summit. And again, just to emphasize, you've got a shear band cutting through here, greatly elongated and stretched out minerals, including quartz. Lots of ductile shear as you approach the Chomolungma detachment. This is another one from right near the base of the Hillary Step where the Chomolungma detachment is. And again, just to emphasize the ductile strain that's evident in this rock right here, even though it's mostly carbonate. So what was the depositional setting 470 million years ago? Was it shallow or deep water? Was it a continental shelf? Was it a reef? Was it a carbonate bank like the Bahamas? Well, we need to do more work. We need to identify more fossils, have a more complete study on our rocks, which we're just now getting into. But as a working hypothesis, I'm going with my my model of a carbonate ramp right here. And I won't get into all the reasons why I think it's a carbonate ramp right here, but I'll just throw out the Yucatan Peninsula as an example where it gets gradually deeper as you go off the near shore into deeper water. It's a true ramp, in other words. So you've got shallow water back here, gradually deepening off in this direction towards the north. Okay? And part of my reason for thinking it's a carbonate ramp is based on more complete fossil assemblages that have been described by Chinese geologists along the Rongbuk Valley to the north. But in this paleogeographic reconstruction, that would be the ramp setting right in through there. This is 200 million years ago, a simplistic diagram, but again, there would be our carbonate ramp, at least in Triassic time now. And this takes us to early Triassic, 237 million years ago, showing India tucked in here. This is all Gondwana, part of Pangaea. Here's Paleotethys right up here. Here's the Tethys Ocean, or Neotethys, opening behind here. And there's a series of terrains offshore here called the Chimeria terrains. These are exotic terrains, very similar to the tectonostratigraphic terrains that accreted to form Alaska, British Columbia, Washington, Oregon, and California throughout Phanerozoic time in North America. And so as India collided with Southern Asia, those terrains were accreted in advance, and we see them forming mountain ranges up here in Central Asia. So this is a total cartoon now, but again, this shows the Cimmerian terrains right in through here as Paleotethys closes through subduction, and then Neotethys closes through subduction, and eventually India collides with everything. So up here to the north, we have Siberia. This would be Siberian crust with upper mantle. The first big terrain to accrete is Songpan-Ganzi terrain, creating the Kunlun Mountains, the Kunlun Suture. And then Paleotethys is subducted as an oceanic slab, creating the Jinsa Suture zone in through here, the Quintan terrain. And then Lhasa terrain comes in here with the BNS Suture zone. And then eventually Neotethys is subducted. You end up with the Indus Zangbu Suture Zone, ITSZ, right in through there, and the uplift to the modern-day Himalayas. So there was a lot of tectonic activity that was accreted and going on to Eurasia long before India arrived on the scene. India was just the last of several big accretionary events, basically. One of my favorite images, of course, showing the space shuttle over the Himalayas looking to the west. Here's the arc of the Himalayas representing that final uplift, and off to the north, all these terrains extending up into Central Asia. So going to the late Jurassic, 152 million years ago, India is starting to think about breaking away. What was going on here late Jurassic time? Well, we had the Morrison Formation. Here in Montana, we had critters like that roaming about. Late Cretaceous, 94 million years ago. There's India on its way towards accretion to the north. What did we have here in late Cretaceous time? Maiasaura, the good mother lizard, was roaming around. State fossil of Montana. Also had a few things happening in this part of the state, I think. Boulder Batholith was intruded 76 million years ago. Homestake Pass, of course. And, of course, mineralization at Butte. The KT boundary, there's India about halfway on its journey. The KT boundary impact. And now we're getting close, Middle Eocene, 50.2 million years ago. India is about ready to dock at this point in time. You can see the classic diagram showing the progressive northward motion of India at this time as the Indian Ocean opened beneath it, essentially driving India to the north. And so the collision occurred in round numbers about 50 million years ago. And this we call the Eo-Himalayan metamorphic event. Tight isoclinal folding, high-grade regional metamorphism occurring at this time at mid-crustal depths. Just a close-up of these rocks, you hike through these gneisses all the way from Lukla to Everest Base Camp. Incredible fold patterns that you see all along the trekking trail to Mount Everest. In our neck of the woods at that time, well, we had the eruption of the Absaroka Highlight Volcanic Field down by Bozeman, for example. The Chalice Volcanics in Idaho. The Absaroka Volcanics down on the east side of Yellowstone National Park. And so here we are training for the Everest expedition. This is volcanic rocks up Highlight Canyon. Basically erupted when India slammed into Eurasia. Igneous dikes down in the Paradise Valley intruded at that time. And so we have gone, as we trekked in from Lukla along the trace of the main central thrust all the way to Mount Everest, the South Tibetan Detachment, the STD. An unfortunate three letters thrown together, but it stands for South Tibetan Detachment. And this took us across the entire, what's called channel flow region of the Greater Himalaya, the Higher Himalaya. This is a concept that was developed by Clark Birchfield many years ago in a GSA special paper. The main central thrust is a thrust fault, hanging wall up, foot wall down. Chomolungma Detachment is a normal fault, hanging wall down, foot wall up. That means that everything in gray here is being squeezed out like toothpaste coming out of a tube. It's being extruded. Back here underneath the Tibetan Plateau is basically a factory of leucogranite that's being generated by partial melting. And so this is reversing that cross-section. Here's southern Tibet. Here's the leucogranite melting factory back underneath southern Tibet with high heat flow. Normal fault detachment, thrust fault at the base. The entire channel is propagating towards the surface. This is the Greater Himalayan Slab. What is driving it most likely, in addition to tectonics, is the monsoonal weather pattern. This is the area of greatest erosion, and therefore, just like melting the top of an ice cube, this is where you're going to have greatest rebound take place. So it's quite likely that climate is actually a major factor in driving the tectonics of the Greater Himalayan Slab. This shows some of the leucogranite which is generated at the top of the channel, and Mount Everest would be located in a position right about there. This is what the leucogranite looks like, in an endless variety of boulders. This one is boudinaged here. There's several episodes of leucogranite intrusion. They're all basically Miocene in age, though. They're like 17 to 18 million years old. Little dikes, sills, big bodies. Here shows leucogranite sills and dikes on Nuptse. That's called the cobweb wall on Nuptse. Here's a big pluton of leucogranite down here. Massive leucogranite on Nuptse. All again, yesterday's granite, 17 million years old. The top of that channel is marked by the Chomolungma detachment, and we can see the Chomolungma detachment from Camp 2. All the leucogranite is below it. There's no leucogranite above it, at least that we know about. Maybe. My grad student thinks he's found some. We'll see. If he has, that's going to be significant. This shows the Lhotse detachment, which is another arm of the Chomolungma detachment coming down into the Khumbu Glacier here. Here's Miocene leucogranite right here. Everest series right there. There's Lhotse. This is just looking down on those leucogranites from the South Col. This is Camp 2 down here at 22,000 feet. You're looking down from about 25,000 feet, essentially straight down. This is out of the window of my tent at Camp 2. I'd look up, and there's the Lhotse detachment, leucogranites to the right, and beautifully folded Cambrian-Ordovician metadolomites out the window there of the tent. The last phase, of course, of the collision is continued indentation of India and the lateral escape tectonics of all of Indochina. Well, we did have a blessing ceremony as we marched into Everest Base Camp in a village called Pangboche by this great Tibetan monk called Lama Geshe. And he blessed everyone in the expedition, gave us prayer flags, and he gave us a card. And I won't read this whole thing here, but it goes, he says, through the play of the currents and waves of the ocean, the Earth's particles gathered and emerged as the first mountains. The humidity produced by the evaporation of the ocean produced the dew, and through the effect of cloud, the snow peaks and the glaciers. He basically got it. He basically defined in his own way channel flow tectonics of the Greater Himalaya and the fact that Mount Everest literally rose from the seafloor of the Paleotethys Ocean on the northern continental shelf of India. And so quite literally, it was born from the seafloor. This is all the members of our expedition, Conrad Anker. There's my hero, Donaru Sherpa. There's my grad student, Travis. These were all our climbing Sherpas in through here, our base camp staff, climbers in the front row. That's my ugly sunburned face back there. This was summit day for Montana State. Here's our equipment on the summit when Donaru did his collecting. And I went overtime, I think, a little bit. Sorry about that, but that's the end of it. Thank you. Sure.
How high up did your grad student make it?
Less than me.
Oh.
Yeah. Above Camp 1, he got a chronic